Peace be upon everybody and good evening. Thank you for having me. I am sorry for not able to attend physically to the conference. I hope my presentation might give some input for the audience today. The title of my presentation is Global Auto Industry Decarbonization. One size doesn't fit all. Toyota is the largest automotive company in the world based on the number of car sales globally. The former CEO, Akio Toyoda, has quit his position recently and passed it to Mr. Koji Sato. Under Mr. Toyoda administration, and even under Mr. Koji Sato administration, Toyota did not commit to go for battery electric vehicle as they believe on multiple solutions for decarbonization of passenger transportation. One of his statement, Mr. Toyoda's statement, that invites criticism is stated here, quoted as he's saying, just like the fully autonomous cars that we are all supposed to be driving by now, EVs are just going to take longer to become mainstream than media would like us to believe. He has been criticized by investors and several environmental groups as not going green. This might be one of the reasons, among others, that led to his resignation. However, we could not simply accuse Toyota for not keen on decarbonization of automotive industries, as Toyota are known for their success in introducing hybrid vehicles into the market since year 1997 and dominate the world hybrid vehicle market since then. Not much progress has been seen by Toyota to produce the battery electric vehicle. The biggest automobile manufacturer in the world, Toyota remained among the lowest company producing battery electric vehicles. In contrast, production and sales of battery electric vehicle dominated and championed by US and China's automotive companies, namely Tesla and BYD. The question is why Toyota did not focusing onto the battery electric vehicle as other automotive manufacturers. Decarbonization of all economic sectors accelerated with the Paris Agreement in year 2015. Almost all countries in the world agreed to mitigate the climate change by reducing greenhouse gas emissions, and the optimistic target was set to achieve up to 1.5 degrees Celsius global temperature increase above pre-industrial level. This graph is showing the global carbon emissions since 1970 and expected control level up to year 2050. This is the line of the set target for decarbonization until year 2050, while this is the line showing the increment of carbon dioxide emissions since 1970 until 2021. This line is for 2 degrees Celsius global temperature increase. Both lines seems difficult to achieve with current progress. Since the Paris Agreement in year 2015, in order to meet the set target, many automotive industries players start to replace their internal combustion engine powertrain to other alternative powertrain, mainly battery electric powertrain. Tremendous effort has been made to increase the global electric vehicles share in the market. In year 2022, electric vehicles already covers 13% of global passenger vehicles. With this exponential trend, the total decarbonization of passenger vehicle could be achieved in year 2050 with assumption that each electric vehicle is producing zero carbon dioxide emission. The problem is this is not always the case. From this graph, it can be seen that in average, battery electric vehicle can contribute to a lower carbon dioxide emissions by about half of an internal combustion engine vehicle. The dot point is the average value. However, battery electric vehicles have not always producing zero carbon dioxide emissions. It depends on the source of the electric supplied to the electric vehicle. If the battery electric vehicle is charging with electricity produced from fully renewable sources, the carbon dioxide emissions from this battery electric vehicle can be zero. Unfortunately, many countries in the world are still heavily depending on carbon-based fuel to produce electricity. The shocking truth is that there are still many countries in the world, including my country, using coal to generate electricity. Coal emits 820 grams of carbon dioxide equivalent per kilowatt hour of electricity produced, which is the highest out of all the fuel types as compared with natural gas of 185 and petroleum oil of 267 gram carbon dioxide equivalent per kilowatt hour. Sources of energy that are considered not producing carbon dioxide emissions are nuclear, hydropower, wind, solar, bioenergy, and other renewables. In other words, if you are using a particular battery electric vehicle in Iceland or Paraguay, you will be producing less amount of carbon dioxide as compared if you are driving the same battery electric vehicle in India. If you drive a battery electric vehicle in US and in China, you are still producing carbon dioxide emissions of about 202 and 258 gram carbon dioxide equivalent per kilometer relatively. As of Malaysia, the average carbon dioxide emissions, if I drive a fully electric vehicle here, is about 212 gram carbon dioxide equivalent per kilometer. Of course, the type and size of battery electric vehicle will churn out a different level of carbon dioxide emissions. As an example, if you drive a Tesla Model 3 in Malaysia, you are going to produce a lower level of carbon dioxide emissions as compared if you are driving Tesla Model X, which is an SUV. However, we can average it into a single number of carbon dioxide emissions of a medium-sized electric car for an electricity mix of a particular country. For Malaysia, it is about 212.4 gram carbon dioxide equivalent per kilometer. Interesting point I would like to make here is that a certain small internal combustion engine vehicle can even have a lower carbon dioxide emissions as compared with battery electric vehicle. In general, any petrol power vehicle which attains a fuel economy greater than 15.5 km per liter is cleaner than the average electric vehicle operate in Malaysia. Many existing internal combustion engine vehicles and hybrid electric vehicles are capable of routinely exceeding this figure. This is happened because electricity source produced in Malaysia is still producing a high level of carbon dioxide emissions. In order to reach decarbonisation in Malaysia, in current situation, do you think you will promote battery electric vehicle or a small internal combustion engine vehicle or a hybrid vehicle, perhaps. Electrification of the entire passenger vehicles for the whole world will only able to reduce by maximum 6.64% of the global greenhouse gas emissions, with assumption that battery electric vehicle emit zero carbon dioxide emissions. Up until 2022, market share of battery electric vehicle is 13% globally. And as stated earlier, electrical grid are still not up to our expectation. This means that up to year 2022, the carbon dioxide emission reduction from battery electric vehicle initiative contribute less than 0.8% globally. The progress is too slow to meet 1.5 degrees Celsius global temperature increase above pre-industrial level. Something has to change in our approach. If we look at well-to-wheel greenhouse gas emission from biofuels, most are having significantly less than its fossil fuel counterparts. Take an example of sugarcane ethanol biofuel. It's only produced less than 30 gram carbon dioxide equivalent per kilometer as compared with gasoline with more than 150 gram carbon dioxide equivalent per kilometer. Soybean methyl ester, which is a type of biodiesel made by soybean, is having only about 40 gram carbon dioxide equivalent per kilometer as compared with conventional diesel fuel with also above 150 gram carbon dioxide equivalent per kilometer. We can take Brazil as an example of a country using sugarcane ethanol fuel for 73% of their cars. 92% of all new sold cars in Brazil use ethanol fuel. US EPA regarded Brazilian sugarcane ethanol as an advanced biofuel due to the reduction in Brazil's GHG emissions by 61%. Here, would you think Akio Toyoda's standing point of view totally wrong? Different countries may require different measures to combat the increase of greenhouse gas emissions. One size doesn't fit all. Based on this chart, Indonesia and Malaysia should not go for the battery electric vehicle, at least for now. We should follow Brazil. I will tell you why. 84% of global palm oil production are coming from Malaysia and Indonesia. In total, palm oil tree plantation land covers about 20 million hectares. Palm oil can be used mainly as cooking oil and biodiesel. Previously, biodiesel made from palm oil was exported to European countries, but nowadays they impose a sanction towards palm oil industries with a list of allegations such as deforestation, peat soil usage, endangered animal species, and inappropriate palm oil manufacturing process. By year 2030, no biodiesel will be exported to European countries and there will be an excessive supply domestically. Indonesia have already imposed 30% palm oil biodiesel content in their diesel fuel, while Malaysia implementing 20% biodiesel content in our diesel fuel in order to mitigate the excessive supply. Deforestation due to the plantation of palm oil tree was an action that has been done in the past. Let's admit that it was bad. It contributed to a higher GHG emissions into our atmosphere. However, we cannot reverse the process. The plantation is already there. What suggestion do European countries have for us at this tropical climate to generate renewable energy? We do not have desert to install solar panels. If we do want to install solar panel, we still need to use some of our forest land to do it. Therefore, what we can do now is to use whatever available in our possession, in this case, palm oil, to mitigate the hike of GHG emissions. Malaysia and Indonesia should use more palm oil or other palm-based biomass locally as main source of our fuel, either for transportation or other energy generation purposes. Instead, adopting solution that is not really effective for our local situation, Malaysia and Indonesia should focusing on using their own available biofuel for their transportation industry. Incentives should be shifted from fully electric vehicles to a small diesel powered vehicles or diesel hybrid powered vehicle. This will not only contribute to actual reduction of GHG emissions from our transportation sector, but also can improve domestic agricultural sector of economy. When palm oil industry have sufficient demand, government should impose regulations to the palm oil industry players to improve their management and production methods in order to further contribute to lower GHG emissions. On top of that, further R&D should be done to produce a better quality of biofuel and better diesel vehicles that can reduce more GHG emissions and at the same time meet customer needs. Some might skeptical with the use of diesel vehicles. General perception is that diesel vehicle will produce bad emissions that can affect environmental and human health. Have you seen any new diesel vehicles with black smoke come up from their exhaust tip? Diesel vehicles have been advanced tremendously in the last few years thanks to Dieselgate tragedy in year 2015. Nowadays, soot and NOx emissions can be controlled as shown in this figure by using all these available diesel technologies. Crude palm oil will undergo a very long process before it can be used as biodiesel. This will infer costs to the production of biodiesel. With the current crude palm oil price, the 100% palm oil biodiesel will cost double of that conventional diesel fuel cell in Malaysia. That means that the higher percentage of palm biodiesel introduced into the diesel fuel, the higher the cost of producing the blended diesel fuel. Even though the use of biodiesel might help to reduce GHG emissions, cost effectiveness of the usage must be taken into account to ensure attractiveness and sustainability of using biofuel. One of the methods to use palm oil in a cheaper way is by using crude palm oil without transforming it into biodiesel through trans-esterification process. Since the most problematic issue that incur of the use of straight vegetable oil is the gumming issues, we can use crude palm oil that completed the process of degumming. No need to bleach and deodorize the fuel. Bleach is for color and deodorize is for odor removal. Not really required this stage for the fuel usage. What are problems related to the use of straight vegetable oil as diesel fuel? First is due to the high viscosity and low volatility of straight vegetable oil that can cause an incomplete combustion, which will lead to formation of carbon deposits on the fuel injectors, piston, and cylinder head. Second, due to the high viscosity, as it can cause premature wear of fuel pumps and injectors, and can also dramatically alter the structure of the fuel spray coming out of the injectors and increase spray penetration. All of these changes to the fuel spray will tend to increase wetting of the engine internal surfaces with the fuel, leading to an increased tendency to form carbon deposits and dilute the lubricant. Generally, diesel engines with vegetable oils offer acceptable engine performance and emissions for short-term operation. However, long-term operation results in operational and durability problems. Some investigators have explored modifying the vehicle to preheat the straight vegetable oil prior to the injection into the engine. Others have examined blends of vegetable oil with conventional diesel. These techniques may mitigate the problems to some degree, but not eliminate them entirely. Studies shows that carbon buildup continues over time, resulting in higher engine maintenance costs and shorter engine life. In conclusion, if somebody can come up with method that can reduce carbon deposits and lubrication oil contamination of diesel engine fueled with straight vegetable oil in a long duration operation, straight vegetable oil can have better prospect as an alternative fuel. One of those methods that can be considered is through emulsification of straight vegetable oil or crude palm oil. Emulsification can help improving diesel combustion by a phenomenon known as microexplosion. Microexplosion is a secondary atomization due to the evaporation of water droplets inside the emulsion fuel, which will further reduce the fuel droplet size and improve atomization process. This is expected can reduce carbon deposit and lubrication deterioration in the long run of diesel engine operation. A 200 hours durability test of using emulsion fuel with 10% and 20% of water confirm the capability of emulsification. However, this study is for conventional diesel emulsion fuel. Crude palm oil emulsion is yet to be tested. An initial test has been conducted to measure the engine performance and emissions of a small diesel engine fueled with crude palm oil emulsion. We took two sets of data for 2900 rpm and 3200 rpm and varies the engine loads from 1 kilowatt to 4 kilowatt. Test fuels are conventional diesel, or here stated as ordinary diesel fuel, neat or 100% crude palm oil, emulsified crude palm oil with water percentage of 5, 10, and 15%. In terms of fuel consumption, it can be seen that the neat crude palm oil is significantly higher than conventional diesel fuel, with maximum of 17% increment due to its lower calorific value of about 21.3% as compared with conventional diesel fuel. However, emulsified version of crude palm oil improve with the increase of water percentage in the fuel. level of fuel consumption become closer to the conventional diesel fuel, especially at higher engine loads. NOx emissions for conventional diesel fuel and crude palm oil is at approximately same level, but for emulsified crude palm oil is obviously reduced as water percentage in emulsion fuel increase. Smoke opacity is significantly higher for crude palm oil as compared with conventional diesel fuel. Emulsion fuel with 5 or 10% water percentage have a tendency to lower the gap between those two. Something should be done to make the smoke opacity of emulsion fuel become at the same level or lower than diesel fuel. Among other suggestions are blending the crude palm oil with conventional diesel fuel before emulsification, or introduce hydrogen gas into the emulsified crude palm oil. As conclusion, something need to be done so that crude palm oil can be used as diesel fuel at a cheaper price for domestic use. Malaysia and Indonesia should not only rely on electrification solution alone. It will take some time for both countries to have cleaner electrical power supply, widespread fast charging stations, reasonable electric vehicle retail price, and other issues related to electric vehicle. Within the time, we should concentrate to reduce GHG emissions as soon as possible using our local resources of energy. That's all from me. Thank you for your attention.